Okay, so today's topic is bipolar junction transistor, which is abbreviated as BJT. We all know the basic structure of a BJT. Somewhat looks like this. We have normally three terminals. We have emitter, we have base, we have a collector. Now, if you look at the structure, we can easily see that the area or volume rather, because ultimately this will be a three-dimensional device. So volume of if I write volume as V, then V of E will be in between the volume of base and the volume of collector, right? So firstly, which we must understand is that the device is created such a way that volume are not same, right? If you go from left to right and if you go from right to left, they are different. The emitter has a volume which is in between base and collector, but the collector has the highest volume and emitter has the base has the lowest volume, right? So this is the first thing we must remember, right? We'll see why this is so, but first we must remember this. Second, we must remember that the doping concentration in emitter is always greater than the base and collector, right? So I can write it like this, right? Type of dopant and everything that will be discussed later, but first of all, if we talk about the numbers only, right? So in terms of numbers, the doping concentration of emitter would be much larger than both base and collector. So that is another thing. These two things have to be there, otherwise BJT will not work, right? Now, if we come to the next part, we know that BJT is either NPN or PNP, right? Which means that emitter and collector has same type of doping and base has just opposite doping, right? And another thing I must add here, that we know the symbol of a BJT is like this, right? Now there are two types of BJT, so we must be able to distinguish them both, right? One is this, another is this. Now if you look at the arrow, if you just look at the arrow, right, what you can see is that the arrow represents the direction of current when emitter and base is forward biased. So first remember that the arrow is always in the emitter terminal. So if there is arrow, I can readily say that this is my emitter, right? And in this case, this is my emitter. And the middle one would always be base, right? Which tells me that this must be the collector and this must be the collector, right? Now, if you put a forward bias between the base and emitter, right, then the arrow dictates the direction of the current. Now in this case we see that current is for the first one. Let me put this first one and this to be the second one. Now we can see that current is moving from base to emitter, right? Now it is in forward bias. We know that for a forward bias, if I have a PN junction, the current is, this is my PN junction, say this is P, this is N. If I put a positive there and a negative there, right, the current path would be from P to N, right? So if the current, in this case the first one, in this case current is moving from base to emitter, that tells me that base must be p type and emitter must be n type. Now we just discussed that emitter and collector has same type of doping. That means this would be n as well. So the first one is my NPN transistor, right? Now you look at the second one. Now in this case current is coming from emitter to base, right? Which means emitter must be p type and base must be n type. Then again collector has to be p type. So this is my PNP. That is the way we distinguish between the symbols of NPN transistor and PNP transistor, right? Now that is out of the way, let me discuss another important part, that is a BJT. BJT stands for bipolar junction transistor, right? Now why is it bipolar? The answer is, let me write it down. In BJT, the current consists of both electron and hole. This is the reason it is called BJT, bipolar, right? So the reason it is called bipolar is that in BJT the current consists of both electron and hole, right? Both type of carrier is there. Why we are talking about junctions? Now if you look at a BJT, as I told you that there will be emitter, there will be base and collector. So this is my emitter, this is my base, this is my collector, fine. Now I also told you it is either NPN or PNP. Let me take NPN first. Both will be the same. Now when you have a N and a P, right, what will happen? There must be a depletion region, right? There must be a junction. Now here junction actually means the depletion region, right? So that would mean there is a depletion region like this in base, and there is a small depletion region in emitter side. Why? Because emitter has higher doping concentration, and we discussed in the last module that if the doping concentration is higher, your depletion width would be lower, right? So as doping concentration of emitter is greater than base, so that means depletion width would be higher in base and relatively lower in emitter, right? Same thing will happen between base and collector, but in this case, as collector has very less doping, the doping concentration in collector would be much higher than that of the base, right? So this is the reason you have junction term in your BJT, because you have two junctions. One is between emitter and base. Normally we write it as JE to point out that it is between base and emitter. It is an emitter junction, right? Because base is common to both. And we write JC to point out that this is collector junction, fine. And there is another term called transistor, right? Transistor simply means transfer of resistor, right? Why is it called so? Because if you look at the device, if you look at BJT from different terminals, the resistance that you will see would be different. If you talk about a resistance like this, if I look from this left side, if it is show 1K, if I look through right side, it will still be 1K. But for BJT, if you look from collector side, the resistance is much higher than emitter or base, right? That's why there is a change in resistor. So there is a transfer of resistor. Resistance is different from different angle. That's why it is called transistor. It transfer the resistor. Now let me discuss the working principle of a BJT. But for that, let me first let me draw the schematic once more in a even larger scale, right? So we know this is my emitter, this is my base, this is my collector. Fine. Now let me put some numbers to this. Let me say this is N, P and N, right? Now let us say that this emitter has a volume V of E is 100 cc, 100 cubic centimeter. The volume of base is only 1 cc, whereas volume of collector is 10,000 cc, right? Or let me just put 100, that will be easier to calculate. 1000 cc, right? Now let me say the doping concentration, right? Doping concentration of emitter is 1000 per cc, and for base it is 10 per cc, and for collector it is 1 per cc. So that is how it is different. Now if I try to find out the number of electron in emitter, it will be around 0. Let us just forget about the commas. So this would be the number of electrons, right? And what about the number of holes in base? It will be 10, right? What about the number of electron in collector? It will be 1000, right? Now first we must remember that for a normal BJT operation, normal BJT, JE is forward bias and JC is reverse bias, fine. So that means this would be negative and base would be positive. And if we talk about the collector junction, then the collector would be more positive than base. That is how you are making it reverse bias, right? Now if you look at the transistor schematic once more, now for forward bias what will happen is, if we just talk about electrons for now, we are forgetting anything else. We just assume for the sake of calculation that no hole is present in your device, right? Just for the moment. So what will happen, as it is forward bias, a large number of electron will injected in the base, right? So that means a large number of electron will go towards the base, right? Let me say that number is injected electron in base is at least 50% of this. So 50,000 electrons are injected into base. So now what will happen? Base has some holes. number of holes in base is around 10, right? So 10 holes will combine with 10 electrons, and number of injected electrons will be now less, right? How much it will be? It will be 50,000 minus 10, which we can just, for the sake of calculation, say that 50,000 itself. So 50,000 electrons are right now in your base. So if I try to sorry, this should be P, right? This is whole, so this should be P. If I try to find out what is the concentration of electron in base, not number, right? Maybe I should put for simplicity, let me put capital for number of electrons and number of holes, and small for concentration, right? So number of electron in base, sorry, concentration of electron in base, you see the volume is 1 cc, right? Now you have 50,000, right? So it is 50,000 per cc, that is the number of electron you have in base. Now what is the number of what is the concentration of electron in collector? It is 1000, right? 1000 per cc. So we can readily see that the number of concentration of electron in base is much larger than concentration of electron in collector, right? And we know that if there is a change in concentration, right, so there is a chance of diffusion, right? Moreover, JC is reversed biased. So reverse biased, right? And if you look at the field normally for the reverse bias case is from N to P, right, which is in favor of the electrons. So this 50,000 electrons is now moving towards collector, right? So you see from emitter to base, this is my drift because of forward bias, but for base to collector we have diffusion because reverse bias, right? So in BJT we have both forward bias as well as reverse bias for the conduction of current, right? Now if you look at the electrons, right, if I just point out with a different color, let me take this. So we see that as it is forward bias, there would be some holes that will move from base to emitter, right? And some holes which are the minority carrier in minority in collector will also move towards base, right? So there is a movement of holes from collector to base to emitter, right? So that means the total current that we'll see, which we normally write either IC or IC for obvious reasons, because collector is the terminal from which you take your current, right? So IC is actually due to both electron and hole, right? That is why it is bipolar. Thanks. Will be next we'll come with another topic.